Hi everyone, good afternoon. So before I start demoing my final year project, I will show you that the dataset that I retrieved from. So one of the dataset that I retrieved from is from the fake news net prepared by Su et al. 2018, and the dataset can be found under the dataset folder. And another dataset that I retrieved from is from Kaggle by Climate. So here is the dataset that I retrieved from. So now I'm going to demo my final year project. So here is all the library that I use for my final year project. I click run. So wait for a moment for it to open the buffer. So at here it needs some time to open the tensor as I using the TensorFlow and Keras. So it takes some time to open the library before it can execute all the library in here. So after that, after execution the library, so I proceed to the dataset that I retrieved just as I mentioned just now from the fake news net and the Kaggle. So they have two dataset, which is true dataset and also fake news dataset. So I assign them to each to one of the variable true and false. So I run, and here is the example of the true, which is the real news CSV file. Then after that, so here you have ID, news, URL, title, tweet IDs, and label parameters. So then I will proceed to generate a general image that mostly the words used in the true in the real news in the Twitter, and also the general words that mostly used in the fake news Twitter. So I will hit run. So I will use word cloud to generate the image, as it has the word cloud library that we'll use to generate the image. So this is the length that will this is the maximum word that will display in the image, and this is the size of the image, and this is the height of the image, and this is the color, and the background color is black. So I generate the image using the title of the dataset. So as you can see, this is the image that generate from the word cloud based on the input of the type of the true of the real news CSV. This is the real news CSV generated words that mostly used in the real news. And now I proceed to the fake news, the mostly used word in the fake news based on the word cloud library. So at here it also same using it will generate maximum one it will display maximum 1600 words with the image with width of 1000, height is 800, the color map is set 3, the background color is also is black. Then here is the generate is the this is the mostly used word in the fake news dataset. Then after that I'll proceed by changing a label instead of real I will change it to 1, and false I will change it to 0. So at here I will use true label equal to 1 and false label equal to 0. Then I execute the command. Then now I concat both of the dataset into one dataset, which is a big which is the whole dataset into a news called news variable. So I execute it and I display the dataset. So as you can see here, the label of the real news CSV has changed from real to 1, and also for the fake news CSV has changed from false to 0. Then after that I will drop the unwanted column. So here I will only focus on the title and also the label. So because the title is the context of the Twitter, and this is the label to indicate that the context is either real or fake that we'll use to train the model. So I will run the command, and now I will show the after the drop. So here is the after the drop. So we'll left the title and label parameters. So in total, there are 12,884 rows of data. Then I will print the shape of the true and the fake news. This is the total. How much row of data is in the real news CSV and how much that row of data is in the fake news CSV. So as you can see, for the true news, they have 7,676 row of data, whereas for the fake news, they has 5,808 row of data. So after that, I will plot bar a bar graph. So this is the bar graph, as this 0 is the fake news and 1 is indicated as the real news. After that, I will proceed to the data pre-processing, is using NLTK and using string library and also NLTK corpus in stop word to remove the unwanted information from the title. So at here, these are all the self-defined function. Remove punctuation is to remove the full stop, comma, apostrophe, and etc. So here I will use the translate and string to make translate and to remove the punctuation into empty string and use the punctuation library from string. The second defined function is remove number from the title. So it will resubstitute, it will using RE library to substitute all the numbers into empty string that is available that is exists in the title of the dataset, of the title column of the dataset. The third function is to define to remove URLs in the title. So here is also using the same RE library sub to substitute all the URL link into empty string that is exist in the title. So here the fourth function is to remove text from the title using the also using the RE library substitute by substitute all the hash symbol or subscribe symbol or dot into empty from the title. And the last function is to remove the stop words. So the stop words is to convert the words from such as like playing. It will convert the playing into play by removing the ing to just retain the words into its base or root form. So this is the function of the stop word. So I will execute. Then here I will apply into the title. Then after that I will use this stop word using the library. Have to download the library. Oh, this is the same as above. Sorry. So this is the same as above. So here you will using the stop by assign a stop variable to set the stop into the variable. By using this, then I will remove the stop words from the title. So I execute the command and I apply to remove the stop words. So here will become it will split into one word by a comma. Then I will lemonize the dataset. Lemonize the dataset. Okay, so I will execute the lemonize will using NLTK stem library. So this lemonizer is a local variable which will call the worknet lemonizer function, and this is a self-defined function lemonize word the text which is the title in the dataset. So this is a local variable for the text in this function. So this is an empty string lemmas. So for words in the text that will split, then the lemma will append lemonize the words in the title into their root base form. Then I will join back into an empty string, join back the lemons. So after I execute this one, I will execute this one. So it will display up here. It will join back without all the commas. So just an empty. So after the lemon ties of the data set, then I will proceed to tokenize and padding the dataset. So the tokenize and padding will use the Keras library, is tokenized library, and also the preprocessed library, as shown in the above here. Tokenized library and also the pre-processing library for pad sequence. So then I will define two new variable. X is to store the title value and Y is to store the label value. Then I will proceed to tokenize. So this is a new variable called tokenize to call the function tokenize. Then tokenize will feed on text on the X. So word to text, word to index is a new variable which will store the tokenized word index, and the X will assign by tokenize dot text to sequence X. So here we'll change the X into a sequence and store back into the variable X. So I will execute the function, the command. Then I will proceed to the vocab size. So this vocab size they will later on use in the embedding layer. So the vocab size is the length of the word index plus 1. So this is the OOV token, which is the out of vocabulary token. It's an indicator to indicate that the word of the sentence is out of vocabulary. And the max length of the padding is 1000. The dimension, the embedding dimension is 100 because I'm using glove 100 dimension text. Later I will explain on it. So I will execute the codes. Then after that, the X will be followed by padding sequence. Padding, so the X will undergo padding function, where the padding function will have X as a parameter. Then the max length is 1000, and if the sentence is too short, it will pad with post inside the sentence. So I will execute. Then I will print X. As you can see here, X is all being changed into the word into the index form, because if you later on use to vectorize it, so as a 0 it will indicate as a post, where pad by the post. Then I will proceed to the vectorization process. So here I will call a new variable embedding index. It's a dictionary function. So f is a new variable which will open the glove word representation provided by the stanford.edu. So it has 6 billion of 100 dimension text file, which is a pre-trained word and encoding with UTF-8. So for each line in the F, the values will be, the line will be split using the split function and assigned into the value variable. Then the word will, the first position of the value will assign to the word. And this is the NumPy library as array, where the value 1 to all with data type float 32 will assign into a coefficient, and this is the embedding index of the words. The coefficient will then assign into the embedding index of the words. Then after that, if you close the F, then I will print the how many embedding index is being loaded of the word vectors. So after that, I will create an embedding metric. I will create a weight metric for the words in the training model for the training model. So this embedding matrix with 0 is also the one of the NumPy library. It will use the vocab size and also the embedding dimension. So for word and I in each of the tokenized variable dot word index dot items. So the embedding vector will, the embedding index dot get the word will assign back into the embedding vector. So if the embedding vector is not none or now, so the embedding metric I, the embedding vector will assign into the embedding metric I, which we'll use for the embedding layer later on. So here I will execute the function, the code. It takes some time because it has a lot of the word representation text file inside the text file. So as you can see, it has 400,000 word vectors in the glove 100 dimension text file. So after that, I will split the x and y into x train, x test, y train, and y test, where you using the train test split by the the scikit-learn library. So the x is the title, the y is the label, the test size is 0.3, which indicate that we are using 70% of the dataset to train the model and 30% of the dataset to test the model in a random state of 53 times. So after that, I will execute, I will print the shape, the x train shape and the y train shape, and also the x test, the test shape, and also the label test shape. So as you can see here, there is 9018 inside the x test, inside the x train, and 3866 inside the x test. So here I will using the TensorFlow library as a TF. So at here the model will consist of a sequential of layers. So it is a sequential of layer. It will the input of the dataset will run through each layer before proceed to the next layer. The output of the first layer will use into the use as an input into the second layer and so on. So here in the sequential model, so this is embedding layer. It must be used in the first, used to train the vector. So at here it will using the vocab size, which I just now declared above. The embedding dimension, which 100. The input length is the max length 1000. The weight is the embedding metric that I created in the using the glove, and is not trainable. Then the output will then forward into the second layer by directional LSTM. So it is a 64 units, 64 dimension, and it has a return sequences is true. So follow the third layer is also a bidirectional STM with 16 dimension, and after that it will dance to connect the neural network as a 64 unit with the activation of ReLU, then drop out to reduce the overfitting of the to avoid overfitting of the dataset by 0.5, and then it will dance one again before calculating the accuracy. So here I will execute the code. Then after that, from the Keras, it will import the backend library as K. So here is the self-defined function to calculate the recall, precision, and also the F1 score. As Keras itself, it was removed the recall, the calculation of recall, precision, F1 score from the Keras library. So I have to self-define the function to get the recall score, precision score, and also the F1 score. Then I will compile the model using the optimizer Adam. If loss is using the binary cross entropy, because here is only label 1 or 0, so I will using a binary cross entropy with the metric accuracy which already available inside Keras. Then I will follow by the F1 score, the precision score, and also the recall score. This is a function name of the self-defined function. Then I will show the model summary. So I will execute the code. And here is the model of the summary. So as you can see, the first layer is the embedding layer with 1000 max length with 100 dimension. The second layer is the bidirectional STM with 1000 max length and 64 dimension, as it is a bidirectional, so it will become 128 dimension. And the third layer is also same bidirectional STM, 16 become 32, and this is the dense with 64 units. Drop out, it will drop out 64 units, and also dense, it will dense 1 unit. So the total params is 1,858,417. So the trainable param is only 105,217 trainable params. So the rest is the non-trainable param, which will not be used in the model. So then I will proceed to the epochs. So this epochs is the epoch value to determine how much the dataset will enter the model again and again. So epoch is, so here it will determine 10. As the epoch will get larger, the execution time will be longer. So I will use 10 instead to show the demo. So I will keep here to run. So it takes some time to execute the value based, it will depends on the performance of the laptops. Sorry, I have to close the video because my laptop cannot afford to open to record the video at the same time during the epoch. The epoch evaluation, as it consumes a huge power, the source power of my laptop. So sometimes I will run this epoch in, it will stop and my laptop will stop working at all. So to prevent that, so I will just now I have to stop the video a while. Sorry for that. So here I will explain about the epoch. So if you're using the 10, so the history is this one. Will show the history is equal to the model fit, where you're using the X train and the Y train with the epoch of 10, and the validation data we're using the X test and the Y test to validate the data. And the batch size is 128. So here is the runtime of the 10 epoch, and here is the loss, the accuracy, the F1 score, the precision score, the recall score, and also accuracy, F1 score, precision, and recall score. So after that, I will test the value by evaluate using the test data, X test data, and the Y test data. So I will execute. So here I will times the accuracy in 100 and show in a 2 decimal place. So as you can see, this accuracy from the using the evaluation using the X test and the Y test dataset to evaluate the model. So it gets 65.49% of accuracy with 75.18% of the F1 score. The value of precision is 62.41% and the recall value is 95.82%. So then I will using the predict in the Keras to predict the model and predict the X test using the X test variable, the dataset, and store into the predict variable. And here I will using the binary prediction for I in the predict variable. If I is larger or equal to 0.5, so it will append to the predict binary prediction. So this array append to it. Else it will not append. So I'll run the code. Then I'll proceed to the metric. It's a metric variable to construct the confusion metric using the binary prediction. The binary prediction is generated by using the Keras predict function. So it will predict against the Y test dataset and normalize all. So it will using the matploid library to plot the figure in a figure size of 1610. So the Excel will using the subplot, and SNS is a Seaborn heat map, so it will display the heat map later on. As you can later you can see after I execute the code. So using the metric is this one. The annotation is true, which will annotate the value in the confusion metric, and AX is the variable. So here is the label, title, and also the tick. So here is the X label, predict label, Y label is true label, and the title is confusion metric. So I'll execute the code. So it will construct the confusion metric as you can see here. So this is a confusion metric of the model So as you can see, there is 0.12, 0.12, that's 0.12, 12% of the data set of the test data set is predicted as a true negative, which is a true fake news, and 53% of the test data set is predicted as a true positive, which is a true real news, and there is 32% is predicted as false negative, which means that the test data set news supposed to be true, supposed to be real, but then it somehow predicted in a negative, so it become a false negative. So here there is a 0.024 percent that is false. This is a false negative, sorry. So this is a false positive, which is suppose the data set is supposed to be fake news, but it indicate as a real news. So yeah, so this the my whole demo of my final year project. That's all from me. Thank you.